In this PowerPoint, we'll look at the two fundamental types of changes that we study in chemistry. These are physical changes and chemical changes. The difference between these ultimately depend on what happens to the particles of matter involved in the change. In physical changes, the identity of the particles involved does not change. This means that no chemical bonds are broken or formed during a physical change. Now, the substance may change form, such as during a phase change. When water boils, for example, liquid water turns into steam. The water molecules remain the same during this change. They just get further apart. During a chemical change, the identities of the particles involved do change. This means that chemical bonds are broken or formed to transform one substance into another. For example, when wood burns, the cellulose fibers in the wood are broken apart and new bonds form with oxygen to transform the wood from cellulose into carbon dioxide and water. And rust is another example of a chemical change. Iron metal reacts with oxygen to form new bonds in a chemical compound called iron oxide. Related to physical and chemical changes, we often talk about physical and chemical properties in chemistry. So physical properties are simply those that can be observed without undergoing a chemical change, or without changing the identity of the particles involved. This can include simple properties such as color, odor, mass, but it can also describe properties that are only observed during a physical change, like boiling point. In order to measure or observe the boiling point of a substance, like water, that substance actually does have to boil. It has to undergo a phase change. And we know that during a phase change, like boiling, the particles don't change identity. They simply change their position relative to each other. They become farther apart for boiling. So boiling is a physical change, and the boiling point of that substance, or the temperature at which that change occurs, is a physical property specific and unique to that particular substance. A chemical property, in contrast, can only be observed during a chemical change. For example, the flammability of wood is a chemical property. So this flammable nature or ability to combust can only be observed if that substance actually undergoes a combustion reaction. In the same way, the tendency of iron to rust is a chemical property of iron. This can only be observed when iron reacts with oxygen to form iron oxide. These distinctions give us another method of distinguishing between mixtures and pure compounds. Mixtures can be separated using physical changes that utilize differences in the physical properties of the components of the mixture. For example, a mixture of sand and salt can be separated by utilizing differences in the solubility of the two substances. Salt dissolves in water, sand does not. So if you mix the sand and salt with water, the sand will remain solid while the salt dissolves. You can now separate the sand from the salt using filtration, which traps the solid particles. Compounds, on the other hand, can only be separated into their component elements by a chemical reaction, a chemical change that breaks the bond between the elements. Compounds cannot be broken down using physical changes. Water, for example, is made up of the elements hydrogen and oxygen. It can be separated back into these elements, but only by conducting a chemical reaction that will break apart the water molecule, like the reaction that takes place during the electrolysis of water. In summary, physical changes and properties do not involve a change in the identity of the particles involved, while chemical changes and properties do. During a chemical change, chemical bonds must break and form. Pure compounds can only be separated into their component elements by chemical changes. Mixtures, on the other hand, can be separated into their individual components by physical changes.